Welcome back, everybody. Today we're getting started on creating a 3D world. So a 3D mesh generated world completely procedurally via code. So in the first episode today, I'm just going to walk through some of the 3D mesh generation basics, what makes up a mesh, blah, 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 the boring theory stuff. And then we'll also get to generating a face or a whole cube, depending on how we go. But yeah, so let's get straight into it. So our world is going to be made up of these cubes. Obviously, a cube has 8 corners, visibly. So to generate it, we obviously have to theoretically put 8 corners and say, hey, draw a faces between these corners, right? Well, kind of. So we're going to generate each face one by one. Face has 4 corners, or we call them vertices in mesh generation. Or some people may call them vertices in general, but that's what we call them in computer language. Every quad or face, every four-sided shape, that's what a quad is, a four-cornered shape, is made up of 2 triangles in a mesh. So 2 triangles make up a square, obviously. And technically, these would now have 6 corners, if that made sense, if we're using a low poly shaded style. However, since both these faces are going to use the same lighting, then we can obviously share their vertices. That's fine. If they were going to have different lighting, then which we'll get into as well, then you would have to have 6 separate vertices for each triangle and all that. So here's what we know, that 3 vertices for each triangle gives us 6 vertices on a square. But lighting, normals, this is what I was mentioning before. So normals determine which way a face is facing and therefore how it is affected by lighting, because this face here should not be affected as much of lighting. If there's a light on this side where my mouse is here, it shouldn't be affected as much as the face on the top. And that's what normal helps determine that. But how can we tell a triangle which way to face? Quite simple. We declare our vertices in a clockwise order, and that way we can determine that our faces, face the right way. So to do this in code, right, we're going to determine a face by creating 4 vertices, starting at 0, obviously, in computers. So we go 0, 1, 2, 3, 4. That's how we're going to determine it. Every vertex obviously has its position. So we have to declare a vertex, give it its position, and say, hey, put a vertex here. And then we're going to, for each triangle, we're going to say, all right, this triangle is made up of the 0, 2nd, and the 1st vertex. And then the next triangle is going to be made up of the 2nd, 3rd, and the 1st vertex. Why am I putting in that order and not just 1, 2, 3? Again, declare it in clockwise order, start from 2, 3, 1. That way, the normals face the right way. If I was to do 1, 3, 2, then my face would be facing the other way. And that is a problem, because then we just have an invisible face. So let's get into coding this. Okay, everyone, so inside Unity, I'm just going to go ahead and create a new material to begin. And this material is just going to be called matte, and I'm going to set the smoothness to 0. And it's just going to be a default material that we can use on our mesh. I'm going to create a new game object, and I'm going to call this cube. And I'm going to reset its position. And now I'm going to create a new C# script, and this is going to generate each cube. So I'm just going to call this cube. And then let's double click the script, open it up. Okay, so we don't need any of this, and we don't need this. For the time being, for this episode, this first initial episode, I'm just going to generate a cube. And then from there, we will move on to generating more cubes, setting textures and whatnot as well. We might do textures in this episode depending on how we go as well. But yeah, so let's see. First thing I'm going to do is create a public. In fact, let's just start with the private void start. Right, and this is going to call a void generate face. We're going to have a different function to generate each face. So we'll worry about that later. For now, I'm just going to call generate face. That's fine. We also need a public mesh. This script to behave properly, it requires a couple of components. So the way we declare a component like that is to simply inside square brackets at the start say require components, type of, and the type of is mesh filter, and the mesh filter is just going to show the mesh. So it's going to hold the mesh, and it's going to be the mesh data. And then we also need a mesh renderer to actually render that mesh. Nice. And then for our mesh to work, we need a list of vertices, well, an array of vertices and an array of triangles. However, since our vertices and triangles, the number is dynamic, since we're not going to always generate every single face in the future, could be since we don't want to generate faces in between blocks. There's no point. It's just a waste of performance. So we're going to use a list to make it more malleable. So I'm going to declare using system.collections.generic. There we go. And now I can declare a list by saying public list vector3. And this vector3 list is going to hold our vertices positions. And it's going to equal new list of type vector3, blah, blah, blah. That's easy. There we go. And then a public list of type int. And the ints are going to be our triangles. Equals new list of type int. Perfect. Cool. That's literally all it is. We will also have UVs and stuff, which we will set. Should I set that now? Probably not worth setting it now, but I will include it just anyway. So I'm going to have a public list of, oh, not that one. Public list. There we go. And UVs are stored as vector2s. So there we go. Call it UVs. It's going to equal new list of type vector2. Cool. Now, at the start, we want to say mesh equals new mesh, just so we can create a new mesh. And then after we generate all our faces, so here we initialize the mesh. And then we create the mesh data from all these faces. And then we set the mesh data. Now, to set the mesh data, quite simple. All we have to do is just say mesh.vertices equals vertices. Mesh.triangles equals triangles, and then mesh.uvs. Well, it would be mesh.setUVs. And we want to set it to the first channel, and then the UVs is just UVs. Now, here's the issue. Mesh.vertices is actually an array of vector3s. Ours is a list. So how do we convert a list to an array? Quite simply, we can just press do to array, and that will do it for us anyway. So nice and easy like that. And then same for this should be UVs.toArray, I believe, but it should take in a list as well. I'll just pass in .toArray just to make it a little bit more consistent. Cool. That should be it, I believe. Cool. So I'm going to rename generate face to generate front face. I'll do. In fact, I will just do front underscore generate face. Just to make it easier when it's auto completing for us. Saves us from having to write as much. Cool, so that's going to do that. I might create another void here to say draw cube. It's just going to be called draw cube. And then I'm going to move this line to draw cube so that I can just call draw cube instead. There we go. Now, generate front face has a, so as we mentioned at the start, well, as I mentioned at the start of the video, how our mesh is constructed is by vertices and triangles. So let's create the vertices. The way we're going to create our vertices is just, we can say vertices.add because it's a list, so we can just add to the list of vertices that we're going to have. What we also want to do is take in a position. So our draw cube is going to take in a vector3 position. All our faces should not take in a position actually, because that's going to be a lot of effort. So I'm thinking rather than even doing this, we might just be able to create a position up here. Yes, we can do public vector3 position. Yeah, we can do that. So public vector3 position, and then here I can just do add position. And obviously our first vertex is going to be exactly where our cube is positioned. So that will make sense in a bit. Our next vertex is going to be positioned at, does that make sense? Front face. this will be position plus vector3 dot forward. And then this will be position plus vector3 dot forward plus vector3 dot up. So this is, in other words, if we're looking at it from the front of the cube, this is the bottom left corner. Then this is the top left corner. This is going to be the top right corner now. So I'm going to do plus vector3 dot forward plus vector forward plus vector3 dot I'll have to do 1. And then duplicate it again, and this one's gonna do plus vector3 dot forward plus, and the reason I have to do dot forward for all of them is because this is going to be 1 unit in front of our mesh, so that the face at the back of the cube is at 0, 0, if that makes sense. As we start rendering them, you'll start making a little bit more sense to you guys. Regardless, so this one's gonna add vector3 dot forward plus vector3 dot right. Cool, that should be all our vertices declared. So I'm just going to say declare vertices. We also need a integer to keep track of the last vertex. And the reason that's important is so that our triangles, when they reference our vertices, it can keep track of which vertices belong where, because they have to reference them by index for the triangles. So what I'm going to do is just create a private int last vertex. Here I'm going to say last vertex equals vertices dot count, so it equals the latest one. And then here I can just say triangles dot add, and for each one I'm going to first do last vertex plus, and then whichever one I want to do. So the way we declare triangles is in blocks of 3. Obviously, each block, well, each line declares it to a certain vertice. So for example, if I say triangles dot add, right, and I add 0, well, plus 0, that's going to reference this one, this line. If I do plus 1, then this one, then 2, then 3. So in other words, I can just do plus. I'm going to declare them like this, add little comments just to keep track of it a little bit easier for us. And you remember from our slideshow, if you want to flick back to that, that's how these are the positions, and that's just the number of that vertice. So now when I do plus 0, obviously I can just do last vertex instead. So we're starting at the bottom left corner, and we have to declare them in clockwise order, of course. So then we're going to go to the top left corner, so I can just say plus 1. Then we're going to go to, of course, the bottom right, is it? Plus vector3.forward.1. No, that one, yes. So plus 2. Yes, and this is actually our first triangle. And remember, each square is made up of 2 triangles, so we need a second one. So I'm going to copy that, paste that here, and this is our second triangle. And our second triangle is going to start at the first index again. This time, I think it's going to go to number 3 and then number 1. Or is it 2? Start it forward, then it will go to right instead. So 3 and then 1. Yes, that is correct. Awesome. And then our UVs will set later when we actually have textures, because that's getting a little bit more into things. So with that all done, I believe that might actually work already. I'm not 100% sure. But so we have this cube game object. I'm going to drag and drop our cube script onto it first, and then drag and drop our material script. With that done, if I press play, we are not setting the mesh. That's why. Okay, so that's another thing I have to do. After we set the mesh data, we also have to actually set the mesh itself. So we can do get component, mesh filter, dot mesh equals mesh. And that will actually apply the mesh to the mesh filter so that the mesh renderer can show it, I think. Here we go, we have something generating, and it is slightly off, it looks like. So there is definitely something in the wrong position here. It looks like, rather than doing the center, if I do pivot, So firstly, one of the triangles is facing the wrong way. It looks like the first triangle is facing the wrong way. And it looks like our third vertex is in the wrong position. Because I'm doing plus vector 3 dot 1. Yes, this should be plus vector 3 dot forward, plus up, plus right. I think it should be plus vector 3 dot right. And then to make that initial face the other way, we'll probably have to switch out these like that and render the face backwards. Something along those lines, I think. Okay. So interestingly, now it's rendering backwards. So if I make this the other way again, if I don't flip them over, then what happens? Still facing backwards. Like this, 2, 1, and then 0. There we go. Perfect. So that is better. Now we just have to do the same for every face. So it's a little bit more complicated. But once you get the hang of it, it makes a little bit more sense. So the one other thing that we also have to do is recalculate the lighting. So that's what I'm going to do now. Recalculate lighting. And the way we do that is, luckily, we don't have to do much complicated stuff for that. We can just say mesh.recalculate normals. And that will do it for us automatically, which is nice and handy. Now, of course, we have to duplicate the front face, which is a little bit of a hassle. But if what I'm going to do is just select all of it, Control C, and then right here, Control V, and then I'm going to name this back underscore generate face. And for back generate face, it's as easy as just getting rid of vector 3 dot forward for each of these vertices. Same with this one. Same with this one. And then we just have to make sure that we flip over the triangles so that they render backwards, essentially. So I can make this one go up there, and then this one go there, and then 2 at the start, and then 3 in the middle. There we go. And that should give us 2 faces of our cube. It gave us 1 face of our cube. Right, because we're not actually calling that function. My bad. We also want to say back underscore generate face. And then that should work. And that's why we have to carry the last vertex, because this cube would not generate if we didn't carry the last vertex. Which is why we have to do it that way. There is a better way to do this so that we don't have to have a separate function for every face. I did try that. Issue is it messes with the UVs. The faces become odd rotated and stuff. And I'm sure there's a way to make it like better. But apart from that, let's create the other faces as well now. So each time we do a block of a face, so if I do right face now, this one's going to be a little bit more tricky because obviously, let me also do right generate face, because now we're dealing with 2 different axes. So our right face is going to be facing obviously the right. So the pos is initially going to be vector 3 dot right. Then it's going to go to pos plus vector 3 dot right plus vector 3. Is it vector 3 dot up plus, yes, vector 3 dot up. Is that correct? The front goes from bottom up, and then, yeah, okay. And then this one will be plus vector 3 dot 1. And then this one is going to be plus vector 3 dot right plus vector 3 dot forward. Something like that. Let me render this and see what happens. Did that work? Yes, it did. Cool. So that's our right face done as well. And you'll see how all these triangles point the same way, this diagonal line. That is important. For the back face, it doesn't. We could make it point the same way as well if we really wanted to, Personally, it doesn't matter too much for them to flip. But you know what? Maybe I should I? You know what? I probably should. If you're gonna do it, might as well do it right. So to make that render properly on the back face, what we'd have to do is start it at, rather than pos, we want to start it at pos plus vector3 dot right, and then we would go to pos dot vector3 dot up plus vector3 dot right, then go to pos dot vector3 dot up, and then go to pos. Yes, and then we will have to probably flip these vertices around as well, these triangles. So like this, like this. So it would be 2, 1, nothing, and then nothing, 3, 2. Yes, so the right face is facing the wrong way. So to make our life a little bit easier, rather than having to rewrite the right face, it's a blessing in disguise. This is actually going to now be our left face. What I can simply do is get rid of vector3 dot right. Get rid of vector3 dot right there. Get rid of vector3 dot right there. And this one will just be not vector3 dot 1. It will be vector3 dot forward plus vector3 dot up. And then I'll have to flip the triangles around as well. There we go. And now that is our left face. Cool. So if I generate this, we should get a left face. We won't get a right face instead. Indeed we do. And they're all facing the right way. Cool. Now we just have to do our right face properly this time. So let me minimize that, copy that whole thing. There we go. Now let's call this right. Then we Control C this, Control V there, and call this right. Give it a couple. Get where? Cool. So our right face is going to start at. Let's have a look. Where is it going to start? It's going to start at vector3 dot right plus vector3 dot forward. So yes, plus vector3 dot right plus vector3 dot forward. Then it will go to vector3 dot 1. Then go to vector3 dot right plus vector3 dot up, and then go to vector3 dot right. I think something like that. Yes, there we go. We have 4 sides of our cube done in the correct rotations of vertices, which is good. And now we just have to do the top and bottom. So I hope you guys are being able to follow along so far. Mesh generation is not meant to be easy. So if it is easy for you at the moment, then you're doing something wrong. So we've done that. Okay, so this is going to be our top face. Top should be easier, he says. So top. So the rotations for our top and bottom don't matter too much because they're not going to be in sync. That said, the rotations for any of them don't really matter realistically, as long as they're facing, as long as the diagonals are going in the right direction. Otherwise, your textures will be rotated in odd ways. So I'm also going to call top.generate face here. For this one, simply going to say plus vector3. This one will start at pos plus vector3 dot up. Dot up, yes. Vector3 dot up. Is that right? No, we will start this at vector3 dot up plus vector3 dot right. Yes. And then we will go to vector3 dot 1, and then we will go to vector3 dot forward dot up, yes. And then we can go to vector3 dot up just as is, and that should give us our top face. Indeed it does. Cool. Slowly getting there. Now we just have to do the bottom face, and then that, ladies and gentlemen, is our cube complete. So let me copy this whole function as well. Just like that. Call this bottom. Nice. For this one, I'll should go to call bottom face here. And the reason these are all separate as well, if you don't understand why I've done that, is so that I can just say, if we need to render the front face, render the front face. If we need to render back, so on. So we're not wasting time rendering faces which aren't even going to be visible. And it also optimizes the mesh a lot. Otherwise, because a mesh can only have a certain max number of vertices, for those who didn't know. It's a very large number, but that said, that number, especially when dealing with a lot of vertices and a lot of cubes, fills up quite quickly, a lot more quickly than you would imagine. That said, let's do the bottom face really quick. So for this one, it will start at a vector 3 dot up, and then yes, so it will start at vector 3 dot up. No, it will start at pos, then go to pos plus vector 3 dot forward, then pos dot vector 3 dot forward plus right, and then pos plus right as is. And that should give us our bottom face. And it does. Perfect. So we have a fully generating cube. Nice and simple. There we go. We have a cube. Perfect. And this will be fully customizable with its material and everything as well. Yeah, cool. That worked. Nice. Oh my god, that was a hassle and a half. But we have done it. Shall we add textures? You know what? No, let's not add textures. We'll do that in the next episode. Yes, in between episodes, I already have my textures here ready. I'm just using the same Kenny assets that we did for the 2D Sandbox series. They're all ready for me. If you guys want to, in between episodes, go get some of your own textures, or there will be a link to this where you can get these textures from in the description. But yeah, so what we're going to do in the next episode is create some UVs. Well, we have the UVs created. We're actually going to utilize them and have some textures generating on our cube. So we have the grass textures and everything rendering, make it look nice and pretty. But yeah, that's it for today. I will catch you guys in the next one. Take care and peace.